this video, I'll be talking about a new Python type, the dictionary. To see how it can be useful, imagine this situation. You work for the World Bank and want to keep track of the population. Now suppose that you want to get the population of Albania. First, you have to figure lists and use the index to connect corresponding elements in both key value pairs. In our case, the keys are the country names and the values are the corresponding populations. The first key is Afghanistan and its corresponding value is 30.55. Notice the colon that separates the key and the value here. Let's do the same thing for the two other key value pairs and store the dictionary under the name.
Got it. I don't know what it's supposed to. Oh my God, Germany. I guess I didn't.
Keys are the country names and the values are the corresponding populations. The first key is Afghanistan and its corresponding value is 30.55. Notice the colon that separates the key and the value here. Let's do the same thing for the two other key value pairs.
Got it. Fuck you.
Value is 30.55. Notice the colon that separates the key and the value here. Let's do the same thing for the two other key value pairs and store the dictionary under the name world. If you now want to find the population for Albania, you simply
Fuck, son.
previous video, we created a dictionary world, which basically is a set of key-value pairs. You could easily access the population of Albania by passing the key in square brackets, like this. For this lookup to work properly, the keys in a dictionary should be unique. If you try to add another key-value pair to world with the same key, Albania for example, you'll see that the resulting world dictionary still contains 3 pairs. The last pair in the curly brackets was kept in the resulting dictionary. Also, these unique keys in a dictionary should be so-called immutable objects. Basically, the contents of immutable objects cannot be changed after they're created. Strings, booleans, integers and floats are immutable objects, but the list, for example, is mutable because you can change its contents after it's created. That's why this dictionary, that has all immutable objects as keys, is perfectly valid. This one, however, that uses a list as a key, is not valid, so we get an error. So you already understand how to build a valid dictionary and how to access it using square brackets. Let's see how we can add more data to a dictionary that already exists. Say, for example, that you, an employee of the World Bank, decide to acknowledge the Principality of Sealand. Sealand is an unrecognized micronation on an offshore platform located in the North Sea. At the moment, it has 27 inhabitants. To add this information, simply write the key Sealand in square brackets and assign 27 expressed in millions to it with the equal sign. If you check out world again, indeed, Sealand is in there. To check this with code, you can also write Sealand in world, which gives you true if the key Sealand is in there. With the same syntax, you can also change values, for example to update the population of Sealand to 28. Because each key in a dictionary is unique, Python knows that you're not trying to create a new pair, but want to update the pair that's already in there. You can see this from this printout. Suppose now that your boss didn't see the humor of adding Sealand to the list and asks you to remove it again. You can do this with del, again pointing to Sealand inside square brackets. If you print world again, Sealand is no longer in there. Good riddance. If you remember the discussion of lists from the intro course, you'll notice that operating lists and dictionaries is pretty similar. You can select, update and remove elements with square brackets. There are some big differences though. The list is a sequence of values that are indexed by a range of numbers. The dictionary, on the other hand, is indexed by unique keys that can be any immutable type. When to use which one, I hear you asking? Well, if you have a collection of values where the order matters and you want to easily select entire subsets of data, you'll want to go with a list. If, on the other hand, you need some sort of lookup table where looking for data should be fast and where you can specify unique keys, a dictionary is the preferred option. Now off to some more exercises on dictionaries.
Alright. Europe, Italy, equals music. Bro.
Creatures of my dreams raise up and dance with me. Now and forever, I'm your king.
how we do it, but we'll see. Oh, fuck you.
In the previous keys is perfectly valid. This one, however, that uses a list as a key is not valid. Fallacy of Sealand. Sealand is an unrecognized micronation. Simply write the key Sealand in square brackets and assign 27 expressed in millions to it with the equal sign. If you check out world again, indeed, Sealand is
That's what I did. It's wrong.
I'm the king of my own land. Facing tempest of dust, I'll fight it till the end.
In the previous video, we created a dictionary world, which basically is a nation. Simply write the key Sealand in square brackets and assign 27 expressed in millions to it with the equal sign.
Now and forever.
At the moment, it has 27 inhabitants. To add this information, simply write the key Sealand in square brackets and assign 27 expressed in millions to it with the equal sign. If you check out world again, indeed, Sealand is in there. To check this with code, you can also write Sealand in world.
Okay, so what the fuck? Ah! You're a bitch. Bitch, son. Oh, it's line 8. How do you prove that?
Of Sealand to 28. Because each key in a dictionary is unique, Python knows that you're not trying to create a new pair. You want to
World,
update the
and then
pair that's
Sealand.
already in there. You can see this
So
from this
that's all
printout.
you have to do to print this shit. Okay. You just put this. Oops. Oh, fuck. I'm gonna fuck you up, son. Holy fuck, I do not get this. What am I doing wrong? Alright, we have Europe. We're adding Poland.
In the previous video, to check this with code, we can also write sealant in world, which gives you true if the key sealant is in there.
Sealant in world.
With the same syntax.
I don't know. How do you... Wait. Probably not. Fuck you. Huh? How do I update this shit? Alright, how do I update? Let's rewatch that video again.
In the previous video, we created with del, again pointing to sealant inside square brackets. If you print world again, sealant is no longer in there. Good riddance. If you remember the discussion of lists from the intro course, you'll note you can do this with del, again pointing to sealant inside square brackets.
Okay.
If you print world again,
We just change it. So we're going to do Europe, brackets, parentheses, so on and so forth. Okay. Europe. That's how I spell it. L. Europe. Bracket. What am I printing originally? Australia. Print. Europe. Okay, what did I do wrong? My bad. Boom. What up, son? Boom. Boom. Boom, 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 boom. What? We add what? Use the dictionary. Create a dictionary named data. Use kept. I don't know what you're asking me to do. Oh, yeah. All right, we can do this. What do we need to do?
I was the king of my own land,
We need to create a sub-dictionary.
facing tempest of dust. I of my dreams raise up and dance with me. Now and forever, I'm
Bring this over. Put it all right there. Good, good, good. Alright. Do we have that? That's the first fucking one. So we go Europe. What are we naming this shit? Data? Now, square no, need curly braces, please. Oh, fuck, I know.
learnpythontutorial.com. And I'm still a little bit under the weather, and I do apologize if I sound funny.
I'm the king of my
Anyway, we're gonna do our last dictionary tutorial, and well, dictionary specific tutorial. I'm sure we'll use dictionaries a lot more in our tutorials, but this is gonna be the last specific one, and we're gonna talk about nesting. Nesting is when you put a data type inside another data type. It could be the same data type as, for example, here, two dictionaries inside each other, or a list or something like that. So we're actually nesting something into another data type. And the reason why I want to talk about this is how do we access the inner data type. So we're just going to work with dictionaries because it's basically the same for lists. And we're just going to create a dictionary, and then we're going to work from there. We're going to learn how to access it, how to change the value, how to delete the value, and how to create a new value. So just to help your Python knowledge a little bit here. So we're going to create a dictionary. A is equal to, and curly brackets, and we're going to say name. And then I'm going to say, this is where we're going to nest another dictionary. We're going to do first, and we'll say Tom. And then comma, and then we're going to do last.
Name.
And we'll do my last name, Myers.
Colon.
No, we close
Time
out that
nigga.
dictionary. So
Hold
this
up, bro. Hold up. Hold up. First, oh, yeah. First.
dictionary is nested in this dictionary. And we'll put another one just out here for the heck of it, age. And I think I'm 34, so 34. And close out that dictionary. So what we have here is a dictionary, and inside the dictionary we have another dictionary. So in this case, name is the key, and it's a key for another dictionary. And then we have first and last as keys inside that dictionary. And then out here we have age, which is with name as a key. Alright, so I'll hit return. So the first thing we want to do is access the last name. So how do we do that? We do A, square brackets, just like we did with regular dictionaries, name. So we got access to first key, and then we got access to second key.
A.
So close out your square brackets, and another set of square brackets. And this time we're going to do last and square brackets. Hit return, and we get Myers. So as you can see, what we have to do when we work with nested dictionaries is, or nested data types, is be able to access the first one and then access the second key inside that to call it. So we're going inside this one, and then we go one level down into this one. Alright, so it's pretty simple. So if we wanted to change a value, for example, we change the first name to John. Let's do A, and then we're going to get the first key, name. So now we're inside here. And now we need to get inside here, so we do square brackets first, and then square brackets, close it out. So now we're in this dictionary. Now we want to change the value. We talked about this a couple tutorials ago. We just simply assign a new value by using the assignment operator. And we'll say John. Alright, and hit return. And if we call A, now we can see first name is John. Alright, pretty cool, right? How about if we wanted to add a new item, and an item's being a key and a value in a dictionary? Let's take a look at that. So we'll do A, and then we want to get inside this dictionary right here. So once again, we do name. Oops, it's gotta be in string format. Square brackets, and then this time we're gonna put a new key because we're adding a new item. So our key is gonna be middle. So we're gonna add a middle name. Square brackets, and this is just like adding a new value. If it can't find the key that you're looking for, it's going to insert the key and the value. So
Okay.
middle, because we don't have middle in this dictionary, and then we're going
Equals
to
to.
put a new name, and I'll say Jake. All right, hit return, and then we call it. Now, as you can see, our nested dictionary now contains a middle name, Jake. All right, that's pretty cool. Now, how about if we wanted to delete the one we just put in? Delete middle. All right.
Nice.
We'll use the del method, and then A, since our dictionary is represented by the variable A, and then we're going to say delete, and then we're going to do name. All right. And we have to get back into this level here, so we're going to do
No
middle, square bracket, hit return, call it A. Now, as you can see, middle has been removed from this dictionary. Now, be cautious when you're working with delete. If I would have went something like this,
It's all
and
gone.
name, all right, and I don't specify my next level down, and I hit return, then I call A, up, now we only have age 34, so we lost a ton of data. So that's just something to be cautious about. But that's basic nesting in a dictionary in Python. It's pretty simple, pretty straightforward. You just got to understand, you got to step through the layers, all right? So if you have any questions about nesting in the dictionary in Python, please leave a comment on
Not
YouTube or on our
really.
website at
Yours is pretty
learnpythontutorial.com.
simple forward.
Um,
Alright, let's go back to here. Okay. So, we do. Okay, so Europe. That's that bitch. Data. Yeah. When we called middle, and then we do equal. Haha, son. It equals capital and population. Oh. Give me a fucking hint. Alright. Why is it curly? I can finish it, but I don't understand why it's curly. Yeah, Europe? Really? Okay, data equals curly brackets. Rome, comma. Line 12. Okay. Data equals capital. Figured it out. Fuck. string. Fucking cunt. Line 15. String, my bad. That might be, okay, let's do it like this. Oh. Oh. Boom.
As a data scientist, you'll often be working with tons of data. The form of this data can vary greatly, but pretty often you can boil it down to a tabular structure. Let's have a look at some examples. Suppose you're working in a chemical plant and have a ton of temperature measurements to analyze. This data can come in the following form. Every row is a measurement or an observation, and for each observation there are different variables. For each measurement, there's of course a temperature, but also the date and the time of the measurement and location. Another example. We have collected information on the so-called BRICS countries: Brazil, Russia, India, China and South Africa. You can again build a table with this data, like this. Each row is an observation and represents a country. Each observation has the same variables: the country name, the capital, the area in millions of square kilometers, and the population in millions. To start working on this data in Python, you'll need some kind of rectangular data structure. That's easy, we already know one. The 2D NumPy array, right? Well, it's an option, but not necessarily the best one. Remember that NumPy arrays can only house elements with the same data type? Well, in the two examples we covered, there are different data types. In the BRICS example, the area and population are floats, while the country and capital are string. Their datasets will typically comprise different data types, so we need a tool that's better suited for the job. To easily and efficiently handle this data, there's the Pandas package. Pandas is a high-level data manipulation tool developed by Wes McKinney and is built on a NumPy package. Compared to NumPy, it's more high-level, making it very interesting for data scientists all over the world. In Pandas, we store the tabular data like the BRICS table here in a so-called data frame. Have a look at the Pandas data frame version of the BRICS data I showed you before. You see a similar structure. The rows represent the observations and the columns represent the variables. Also notice that each row has a unique row label, BR for Brazil, RU for Russia, and so on. The columns, or variables, also have labels, country, population, and so on. Notice that the values in the different columns have different types, a big difference with 2D NumPy arrays. This is all great news, but how can you create this data frame in the first place? Well, there are different ways. First of all, you can build it manually, starting from a dictionary. Using the distinctive curly brackets, we create key-value pairs. The keys are the column labels, and the values are the corresponding columns in list form. After importing the pandas package as pd, you can then create a data frame from the dictionary using pd.dataframe. If you check out bricks now, we're almost there. Pandas assigns some automatic.
Okay, how do we... Oh, we're in NumPy. Okay, we're done.
Row labels, 0 up to 4. To specify them manually, you can set the index attribute of bricks to a list with the correct labels. The resulting bricks data frame is the same one as you saw before. Using a dictionary approach is fine, but what if you're working with tons of data, which is typically the case as a data scientist? Well, you won't build a data frame manually. Instead, you import the data from an external file that contains all this data. Suppose the bricks data that I showed you before comes in the form of a CSV file called bricks.csv. CSV is short for comma separated values, by the way. Let's try to import this data into Python using pandas read_csv function. You pass the path to the CSV file as an argument. If you now print bricks, there's still something wrong. The row labels are seen as a column in their own right. Right. To solve this, we'll have to tell the readCSV function that the first column contains a row indexes. You do this by setting the index call argument like this. This time, bricks contains the data frame we started with in this video. It nicely contains the row and column labels. The readCSV function features many more arguments that allow you to customize your data import. Make sure to check out its documentation. Now head over to the exercises to experiment with building data frames yourself.
Create. What am I making?
To Python for Data Analysis Lightning Tutorials. I'm Alfred Essa. Today I want to provide a very quick preview of coming attractions of the Pandas library. We'll be using Pandas extensively for data analysis. The goals of this tutorial are to import Pandas and PyLab. We'll read a CSV file. The CSV file contains a list of the most popular baby names in the US for a period starting from 1880 to 2008. Then we'll perform some basic operations on that data set.
See what you got to teach me, bruh.
and also perform some plots. All right, so let's get started. I've fired up the IPython notebook, and the first few lines, we import pandas and pylab libraries, fairly standard Python commands, and should be self-explanatory. Next, we are importing the CSV file, and we're taking the CSV file and storing it into a data frame object. The data frame object is in the pandas library, and the variable name is called names. So just to verify, I'll issue the command shift return, execute the import, and then also read in the CSV file. Just to verify that everything went okay, I'll type names, hit shift return, and this presents us with metadata about the names object. You can see it's populated by over 250,000 rows. It has columns called year, name, prop, sex, sound X. All right, let's just verify. Let's just take a quick look at the first few records of the data set. And we see that it begins, the data set begins in the year 1880. And we have some data that shows us what the data looks like. All right, now the names and data frame objects in general, many of the Python properties, characteristics such as slicing, you can operate on that. So let's take a look at a few rows in the
I don't even know what
names
he's
data
doing
set.
here,
And
man.
the way we can do that
You don't
is
ever get out of this stupid program here, 'cause I don't
below
have this.
the last 5.
Fuck you.
Yeah, I've solved it. All right, everyone. Good morning. I'm Brandon Rhodes, not the author of Pandas at all. None of it is my fault. But as somebody who has had to learn to use it kind of a bit at a time.
Hello, everyone. Welcome.
Okay.
What is going on, everybody? Welcome to a data analysis with Python in the Pandas module tutorial series. In this series, we're going to be trying to cover pretty much everything you might need to use with the Pandas module along with Python for all kinds of different types of data analysis. So first of all, Python is the programming language. If you don't have Python already, what you'll want to do is head to python.org, and you probably don't have to do print when we say, the data frame head or something like that. If that doesn't mean much to you, don't worry about it. Next, we're going to need Pandas. This is the Pandas website. You could download it from here and install it from here, but we're not going to do that. We're going to use pip. And then finally, this is my website, pythonprogramming.net. All the tutorials, including this one, are posted up here in text form. Sample code is there by doing a simple pip install pandas. Now, and we'll need to install that as well. But nowadays, there's a million ways you can install packages with Python. Nowadays, pip has got to be the easiest way to do it. So that's what we're going to use. If you don't, if that doesn't work for you, I'll put a link in the description for my pip install tutorial. You can always get pandas another way, but I'm not going to waste time on here. Most people should be fine with pip install pandas. Now, once you have that, we go open up here, and then you're ready to put in your data. Now, the question that you might have is, what is pandas? Why would we use this pandas module as opposed to just writing Python code? Because you could take so like pandas, it generally works with data frames. You can work with series too. A series is like a list with a column header and an index. But you could take like a data frame is generally, it's a lot like a spreadsheet, right? If you print out that data frame to the console, you'll see that it looks identical to a spreadsheet with column headers. It's got maybe an index with maybe you've got dates there or a line number or something like that. And then in between, you've got all your data, okay? And so it's a lot like maybe an Excel spreadsheet if you're familiar. Now, why would we use Python over Excel? Well, the reason why we use Python over Excel is Excel, despite the name, is not very fast at all, and it doesn't speed up for you. In fact, as you get bigger, it's going to slow down and not be the greatest. Now, with Python, things are going to be much faster. So I see a lot of people with Excel starting to do machine learning with like maybe k-means or something like this, or k-nearest neighbors or whatever, and it's very slow. I mean, the whole process, even on a very relatively small data set, might take you 3 minutes or something like that, or even on a medium-sized data set. Most people would call it large, but on really a medium-sized, let's say you're dealing with a couple gigabytes of data. Well, first of all, if you're dealing with more than like 2 gigabytes, Excel's going to probably stop responding. But also, it's going to be really slow. It's going to take you like 30 minutes to run even let's say you're not even doing machine learning, you're just trying to do some basic calculations. You're probably going to have a problem. Now, you can tie in Python to Excel and stuff like that, and there's other things, other languages that will tie in and help you speed it up. But eventually, running headless with something like Python or even C or whatever is in your favor. So then why use Python over, let's say, C++? Python is very friendly. It's a lot of people kind of nag on Python saying it's slow, especially slow compared to, say, C++. That's simply technically true, but in practice, absolutely false. Okay, Python is almost as fast. I mean, we're talking 99.9% as fast as C, because Python is written with C. Okay, and a lot of these packages like Pandas, and Pandas utilizes NumPy, that's a C library. It's just a Python wrapper around C. Okay, so because of that, it's going to calculate as fast as C, because it is C. Okay, so Pandas with Python and Python with NumPy and a lot of these other packages that people use for data analysis, it's just as fast, and you get the loveliness that Python brings to the table, which is, you know, really nice. It's obviously static types, but so you've got, you know, the syntax is just easy even for a newcomer to understand it. Usually you can read it and it makes sense. So then finally, why would we use Pandas rather than Python plus, say, NumPy? Well, the reason why you would use Pandas is extremely efficient. It's basically built to make your life easier. So let me go ahead and just show you a quick example. I'm just going to copy and paste this code. Everything that you're going to see here we'll cover in this series. I'm just going to copy and paste the code. If you want to copy and paste the code, head to pythonprogramming.net. The data analysis or dashboard, then the data analysis tab. You can copy and paste the code as well if you want to, but really don't worry about it as long as you're thinking you're going to go to the next video, because we're going to cover the code anyway. I'm going to copy, paste, here's some code. We're importing Pandas as PD here. It's just standard to import it as PD. It's just a shorthand way.
Alright, you know, we're going to take a little break. How long have we been doing this? Say, how long have I been streaming? All this information here. Now how long? Like,
To add this information, simply write the key sealant in square brackets and assign 27 expressed in millions. Good riddance.
Italy.
This video I'll be talking about a new Python type, the dictionary. To see how it can be useful, imagine
I'm the king of my own land. Facing tempest and
in the previous video we created a dictionary world, which basically is a set of key-value pairs. You could easily access the population of